right, so let's get started. Good morning, everyone. Thank you for joining us for the Gaming Guild. And this first. So good morning, everyone. Again, thank you for joining us for today's Gaming Guild. And I want to start by saying thanks to Richard, of course, for joining us. We're very grateful that Richard is sharing his time with us today, and we'll introduce him a little bit more later. But let's start by, of course, talking a little bit about what the Gaming Guild is. So today is the second session, and the hope is for each of these sessions, the attendees get to know a little bit more about how to make games in Web3 and what kind of games we should be making on Web3. Today, we'll be talking about Phaser, which is, I feel, the best engine that we need to use when we're making a richer game on Web3 on top of the smart contracts that we're building. And of course, there's no other speaker to help us out than Richard, who is the creator of Phaser. But before then, I wanted to, of course, introduce the Kernel folks for Richard's benefit as well. The Kernel Block V people are artists from around the world, so not just engineers, but also veterans from Coinbase, Protocol Labs, all of these big companies in Web3, alumni from schools such as Harvard, Oxford, and some of these other great schools. And of course, the genius in music, fashion, gaming, and some of the other diverse backgrounds that the Kernel folks have. And what's very cool is we have three-dimensional humans with incredibly multiple lives, like a quantum computing scientist, a filmmaker, a Bollywood actor. So it's really the diverse perspectives that we need to really create the systems that are going to be significant in Web3 that affects all of us. And of course, the Gaming Guild, what we want to do here isn't just to create games that are, I guess, that are in the moment, like play to earn, but timeless games that would really, I guess, be able to move forward the art form. So we have games like Crypto Raiders and Navigotchi, which are examples of games that are built on Phaser, which you'll talk about later, and some other example games here that I've listed down. So the things that we want to answer are what are the next games that we should be creating? Because as we all know, crypto and Web3 is still very much in flux. There are still a lot of primitives that need to be created. There's still a lot of game designs that need to be explored. And the hope here with the Gaming Guild is we do that and really explore that with the people we bring in the conversations that we have. All right, and then I'll do a little bit of an introduction on Richard. So as I mentioned, he's the creator of Phaser, which is the most successful HTML5 game engine, and one thing very special about it is it's fully open source. So if you look at Phaser and GitHub, it has 30,000 stars. A lot of games have been using it just through these games that are shown here on the bottom of the slide, like games from Marvel, games from Minecraft, some other cool games that Richard will show later as well. And Richard has been building this for, I would say, for how long have you been building Phaser, Richard?
Oh wow, 2013 I started, so yeah, quite a while now.
So quite a while. So there's been a lot of building on top of it, a lot of games, even before Web3. A lot of brands have been using it, and a lot of game developers have been as well. So we're really fortunate to have Richard's experience and really share what he knows about Phaser and also building games on web. And Richard, do you want to also do a little bit of an intro on your end?
Yeah, sure. I mean, do you want me to? I mean, I can kind of like cover that when I start my presentation if you want. So if you want me, I can just kick off if you want. So you got anything else you want to add before I do that?
No, I guess just anything, a short blurb if you wanted to add to that.
Yeah, sure. I mean, so basically, I mean, I've been working on Phaser for quite a long time now. I'm going to be explaining what it is, how it can be used, and then I'll basically go through the process of actually creating a game with it. It's not going to be, a groundbreaking game because obviously we're quite limited on time, and I don't want to dive too deeply into the technical aspects of it. I just want to give you a good sample of what it can do, and then hopefully the idea is at the end of that you can take away basically you can kind of start seeing the little building blocks that go together, and then start thinking, right, how can I apply this to my to my Web3 games? And that's really kind of what I'm hoping people will get out of today's session.
Right. Yeah, thank you for that, and we're grateful for the time you're spending with us, Richard. And I guess before we start, something that I did last time with Austin is we wanted to give you a little bit of the kernel experience, as it were. So I wanted to start with uh, I guess something that I talked about in my talk and Shelling Point a few days ago, wherein I explored society if games were open source. And the thinking here was games have traditionally haven't been open source, right? The incentives have mostly been around trying to capture attention, and I would say that this has been what's led us to the current state of the industry, where the shape of our tools shaped us. So, for example, Unity has really been the main tool that game developers use, and because of that, we kind of are directed towards the incentives that Unity is directing us towards, like Unity ads, for example, and the subscription model, right? So building things on an open source engine like Phaser is very interesting to me. And I guess one question I wanted to ask you, Richard, is what led you to creating Phaser open source? What was the impetus for you to kind of start doing that?
BizDev kasi guilds, strategic partners.
Yeah, sure. I mean, basically, it's open source because I've been building on the web for decades now, and it is traditionally open source. You create something, you push it out there, and other people benefit from it, and then you benefit from them taking what you've done and fixing bugs that they find or adding features that they want in there. And it's just kind of like it's a collaborative ecosystem, and you don't really get that anywhere else. So it was, there was just no point doing it in any other way. That was just the way it had to be done, because it's a browser technology. Everything is built on the completely open source stack, really. So it was just imperative that is how it just married my two favorite things together, which is games and the web. So that's kind of why it had to be open source.
Yeah, and another thing I wanted to mention is, as I said, the tools that we use kind of define the incentives, and one thing that I really one article that really spoke to me was this one by Yanis Varoufakis on techno-feudalism. He mentions that within our present oligarchic, exploitative, irrational, and inhuman world system, the rise of crypto applications will only make our society more oligarchic, more exploitative, more irrational, and more inhuman. And so I wanted to take that as, I guess, as a jumping off point for asking, what do you think is it a good thing for us to make all games open source, or is that something that that we shouldn't do? So I guess something to think about while since you've been building an open source for quite a while.
Yeah, sure. I think there are levels, aren't there? I mean, I think a lot of people, if you would say to like a traditional game developer, right, okay, everything you do from now on has to be open source, there would be kind of like, pushback against that. But it doesn't mean that the entire game needs to be. Yeah, I mean, you can still have assets and IP that you've created be protected. You could open source parts of the game, like bits of game logic, or the ability to kind of like add new functionality into a game. That there's degrees to which you can go down this path. And of course, the entire thing could be completely open source, and you could literally just hand it over to the community and let them evolve on it and create something new from it, which is what we see with quite a lot of the blockchain games that are out there. So I think there are levels, aren't there? It's not black and white. There are ways to which you can do it, and they don't need to be scared of thinking, all right, everything has to be open. That's not strictly true. It's just what they feel would benefit their games and benefit their players. Those are the parts that they need to consider making open.
Yeah, and Andre, is there anything you wanted to add?
Yeah, I wanted to add to this. I totally agree. And with our studio, with Enclave Games, we kind of try to offer as much as possible of the demos and materials that we create during game jams, or materials for tutorials and all the learning stuff you can get. So providing those is one way of connecting with the community. But there's also a different aspect of having deals with publishers in the, let's say, old world of earning money on web games, where you would prefer to not open source everything if you want to do the deals you were doing them in the past years. So building on top of open source demos and materials, having some products not open sourced still work for the ecosystem right now, where you earn a lot of money out of adverts on publishers' websites. But we can push open source and we can explore this in a way that will be revolutionary to what we were doing over the years. And there are so many new opportunities we can explore that I think it's something developers should at least try and see if this could work for them.
Agree. And I guess, of course, it's a perfect segue for Richard to start telling us about Phaser and seeing how we can use it to enable better games on Web3. So Richard, I'll stop sharing the screen now.
Okay.
Yeah.
All right.
And I'll manage the chat, and I'll just chime in whenever anyone has something that they want to ask you.
All right, brilliant. Thank you. Okay, right. Hopefully this will work. Okay, right. Yeah. So, yeah, I mean, thanks for inviting me to talk today. I'm gonna, like I said earlier, I'm gonna basically kind of split this into a few. I'll just keep this brief, just to give you an idea of what Phaser is and what it entails, and then I'll cover, actually building a game, which could be quite fun, I think. As for myself, I mean, I've been a keen gamer since I was born. I think, quite frankly, I've been playing arcade games since the 80s, and I've always loved it. But it was actually when I was at university and the internet really started taking off, and this is right back at the beginning of the 90s. And I remember quite vividly kind of being sat in one of the computer labs, and we had like a beta version of the Mosaic web browser, and they had just announced the feature that it could display JPEGs. And that before that point, it had literally been text only, and we were just kind of like, it was almost revolutionary. You could kind of see that little transition happen. It was like quite a key moment. And from that point on, everything I've done has been wrapped around working with web technology and working with games. And so Phaser literally is the combination of these two passions just brought together in an open source library. Now, I'm going to basically, I'll cover very quickly what Phaser is, and then I'll do kind of like a bit of a background behind it. And then I've got some trailers for some games that I think, I've picked three different games I think showcase the different aspects of what it's capable of. And then we'll jump into kind of some coding. And the coding is not going to get too deep, but hopefully you get to appreciate what you can do and how quickly you can do it. Okay, so as we've said, Phaser is 100% open source, always has been right since the very beginning. It's the current versions, version 3 is built using JavaScript entirely, although we do provide TypeScript for those who prefer developing in that. It has 2 internal renderers, so it will render using Canvas or WebGL, depending on what the device the game runs on can support, so it can switch between the 2 of them. And it's completely built on browser technology. That was its entire point. That was the whole reason for creating it in the first place. So what that means is that you can't use it to create, I don't know, the next PS5 game, for example, but it does let you target anywhere where web technology or web browser technology lives, and that's a huge variety of places. I mean, obviously, you've got like desktop browsers, but then you've also got instant messenger games, or a lot of which are based on web. You've got playables. So, for example, if you kind of like start a game on your mobile phone and it comes up with one of those kind of like, play this demo of a game advert before it, those are like playable demos for other games, and nearly all of those are kind of built with web technology. They're very rarely native. You've also got multiplayer games, so huge kind of like online games and desktop games are running through multiplayer technology. You've also got games running, developers upload to Steam, so you can kind of like browse the Steam library and download an executable and run it straight from your computer. Obviously mobile, iOS, Android, tablets, phones, the whole lot. got smart TVs. We've got kind of phaser games running on smart TVs, which is quite intriguing. There's even a company out there that makes Twitch stream overlays. So you get these kind of little characters jumping around the screen and things exploding, and it's all just controlled by a load of sort of phaser scripts and stuff that they can trigger as they're streaming. And we're also seeing quite a rise in feature phones as well. Feature phones that running platforms such as KaiOS, which they're kind of usually non-touch screen, so they're button-based phones, and the actual handsets themselves cost around $10. So you're talking kind of like really low power technology, but they love games. It's as simple as that. So they basically they're kind of web-based phones, so they can play web-based games, and you can use phaser for creating stuff for that too. I've even seen phaser games running on like Tesla dashboards. So the ability, in fact, although it's web technology, it is everywhere, and it's in far more places than you would ever think, which is kind of what makes it quite exciting. And now we're seeing kind of like on-chain games as well, which also means that you're adding kind of like that layer, but that layer can actually then explode out into all these different areas as well. It's not confined just to the browser. Now, as I said, it takes advantage of, because I'm building on browser, I'm taking advantage of browser APIs, and there are lots of them. We basically, like if you want to go to full screen, there's a full screen API that browsers provide that we can interact with. There's a API for accessing game pads or web audio or the input pointers, all of these things that browsers support, and there are lots and lots of them we can use. And then we basically expose these to the developers through our own API. So you don't have to sit there and spend days scouring the Mozilla documentation to figure out how to get a gamepad to work or to figure out how to get web audio to work. Instead, you literally just type in a bit of code such as sound.play explosion, and you get that. And phaser kind of like sits as like the middle layer between all of it. So that's kind of how it works. It's kind of like a multi-layer sandwich, as it were. And phaser itself provides all these different kind of points of entry. So I kind of treat it as kind of like a burger, basically. So you kind of like at the bottom layer, you've got like asset loading. So the ability to load anything, the ability to load images, audio files, videos, shaders, HTML, anything at all. You can kind of put it in through one unified call, and it sits internally inside of phaser ready for you to use. You've also got an audio layer. So we hide kind of like the intricacies of web audio and HTML audio from you. So you just deal with our sound manager, and that can then apply echoing effects and pan delays and all the things that you might need to add rich audio to a game. We've also got multiple physics layers in there. So there are a couple of different physics libraries that you can choose that are built in depending on what sort of game you're building. There's a really fast one for more kind of like platformy, shooty sort of games, and then there's a full body physics system if you need like proper detailed collision responses. We've also got text handling. Any font that the browser can handle, we can display. Web fonts, bitmap fonts, all kinds of text handling. There's input, so input from a keyboard, input from a gamepad, input from a mouse, input from a touch screen, input from multiple fingers on a touch screen. It's taken years, to be honest, to create the interface to all of those different things through one simple thing for you to use. And then the biggest part really is all of the game objects, so the sprites and the graphics and the images and all the things that you visually see on screen. So there's a whole variety of game objects that you can just like pick from and just blast up onto the screen as needed. And this is kind of like the real meat of the burger, quite frankly. But you can also stick animation on there. So you got a sprite, you want it animated, fine, that's not a problem at all. You can kind of like keyframe animation. You can do animation from packages such as Spine, which allow you to do sort of skeletal animation. So there are a variety of different ways to get motion into your game on an animated basis. But there's also tweening, and tweening is the ability to take something and manipulate its values. So for example, if you've got an object at a certain coordinate, you can say, right, fly over to this coordinate over this time span using this kind of effect. So it can kind of like bounce over there or skid over there or jump over there. So tweenings are like extremely powerful, and I'll actually be using quite a few of them in the example game that I build to show you. Shaders are a whole other level. They allow you to do all kinds of things, from warping screens, twisting things, blending colors, all kinds of really all the really top-end effects that you would see in any game. Tile maps allow you to kind of design your level. So you can use a tile map editor, which is kind of an external bit of software that literally allows you to draw with tiles and place down where you want doors and walkways and platforms and enemies and all that kind of stuff, and export it and load it into Phaser and have it rendered straight away. You've got particle systems, so things exploding, fire bolts, I don't know, rainstorms, anything you think of that is handled through particles can be done. And then kind of like you can package it all off with cameras as well. So camera system allow you to kind of like pan around an entire world or zoom in on a specific spot or even shake it or make the camera fade. And all of these things all kind of stick together and kind of like, your McPhaser burger, basically. That's kind of like, this isn't even all of it. This is kind of the key bits that I picked out, but you've got all of this together, and then this is all sat on top of web technologies, all running in a browser. I'm going to quickly show you a video that kind of sort of encapsulates what I've said, and the video was created using Phaser, so it's kind of a good demonstration of what you can see. So yeah, I mean, look, like it's kind of
video.
it's just a way of showing kind of everything that I just kind of explained a bit more succinctly. However, it's not without its challenges. Building using the web as a platform is a real genuine challenge. Like it says there, 2,200 changes to WebKit and Chromium every single week, and that's just kind of like an average. It literally takes just around 12 weeks. It's actually a bit less than this now to go from Canary, which is like the development version of Chrome, into the live version of Chrome in just literally 12 weeks. So they drop a new feature or they update an API call, we have to be aware of it and we have to react to it very quickly. You've got iOS and Android doing automatic OS and browser updates over the air. So literally one day you can wake up and half a user may Sprite and I'll be running a new version of iOS that perhaps had broke something in WebGL, which is what happened last time. There's a whole lot of things to contend with, which also is quite exciting because basically you can I've had this before. We started a project and it wasn't technically possible to do something, and by the end of it we could do it because it had actually landed and arrived in the browsers. So I do think it's quite important. You need to keep reevaluating everything that you know on a regular basis because it changes a lot. And add Web3 into this mix and you've got a whole new stack of things to deal with because you've got new blockchains appearing, you've got new platforms within those, you've got kind of like APIs that you can use to interact with them, which are constantly being updated and worked on across a huge variety of them. So it's, there's no underestimating the challenge involved here, but at the same time, it's kind of, it's kind of what we live for, quite frankly. It's kind of like all these new things that keep arriving and all of the new chains that keep appearing. That's kind of, honestly, that's what makes it quite exciting. So I built it because I basically built Phaser because I've loved making games since forever. I mean, I really have. I kind of like back in when I was growing up, there were tools, kind of like QBasic, there were Gorillas, there were basically tools that allowed you to code in BASIC and get things on screen fast and really do stuff without any complicated compilation steps or installing all kinds of like dependencies. It literally was just fire up a screen, start coding and go. And I wanted to transport that to concept to the web, because it's really important to me. And that's why a lot of the Phaser API is very straightforward, because I don't want you to kind of like have to be hiding behind complexities. And you know, if you've got a basic understanding of JavaScript or TypeScript, then you should be able to use it. And that was the whole point behind it. Now, like I mentioned earlier, first version released 2013, and 150 versions since then. Actually, it's a full-time project for me. It is open source, but it's the community and sponsors fund my work on it. So I've been working on it full-time for quite a few years now, and will continue to do so for as long as I can, basically. It's exploded. It really has, and I think this isn't just I'm not just kind of like showboating kind of like Phaser stats here. I mean, although it is great that we've got, you know, 102 billion hits on the CDN in a year, more importantly, it's showing that there is, and still persisting, a real appetite for web games. I think it was quite, you know, people thought, okay, no, you know, web games are kind of like have tailed off once mobile came out. But I don't think that's actually true. We're seeing a huge uptake in games, on people playing games on the web. And on web-based destinations, like I kind of listed before, like instant messenger games, for example. So I think it's important to understand that, you know, this isn't a shrinking area. If anything, it's quite the opposite. And, you know, it's just great. It being kind of like a you know, one of the top starred projects on GitHub really gives me a good kind of insight into what people are building, because I can see, you know, when they fork Phaser and what they're using it for. And we're seeing a lot of kind of Web3 games being made with it now, which is it's just great. It's kind of the next evolution, as it were. So I thought it'd be a good idea to just kind of like just show you some games that were made with Phaser. And basically, I picked 3 out, and each one has got a trailer, and they're not too long, for just a couple of minutes each, but they all give a really good, they're the 3 very distinct types of game, which give a good understanding of what it's capable of. So the first one is Nearwood. It's a hidden object adventure game. So a lot of kind of like rich animation and rich graphics. Originally published by Big Fish Games, and who then contracted the Category Ideas studio to kind of do a web-based version of it. So hopefully the YouTube video will play properly.
All these years I've been waiting for you. You are Jane Lockwood, the daughter of Nathan and Elizabeth Lockwood?
have visitors. My name is Ori. Welcome to our village.
Our last human visitor was, Mr. Nathan Lockwood.
I've only seen your kind in pictures and old books.
Thank you so much for helping us. You can always count on our help too, Miss Jane.
Okay, so a kind of a very traditional hidden object game, like visually beautiful, but actually there's nothing in there that is, I'm not trying to downplay the amount of work that went into it, but it's fundamentally straightforward in the sense that it's kind of images and input events and dragging things and combining things together and particle effects and a great story and great graphics to kind of wrap it all together. But it's still it's still not beyond the realms of possibility of any developer out there, really. Dead Switch 3 is a Steam game. It's a multiplayer game. This is entirely less wholesome than Nearwood. It's basically kind of like a side-scrolling version of Counter-Strike. So the video for this one's quite a bit shorter, so I'll just run through it. Oh, no, if I click play, it will anyway. It's a properly fun game. Hang on, oops, hang on, start again on it.
Looks pretty fun.
You can lose far too much time on it. But like I said at the beginning, and like actually you included in your slide, Paul, people are now making on-chain games with Phaser, and I think Avogotchi is quite a good example of one. They're basically kind of like playable NFT avatars on Polygon blockchain, and you can kind of like, it's like a concept, I guess, is the whole kind of like Tamagotchi, but taken to the nth degree, and it's a good fun game, and they've been doing a lot of stuff recently in terms of kind of like expanding it with new bits of land and new types of NFTs. So they've got a really nice, quite short little trailer, so it kind of, which demonstrates kind of how you actually sort of play the game and some of the aspects of it. But like I said, there are loads more, like thousands more. So you feel free to kind of like go and look at phaser.io/games to look at some of the highlighted ones. There's all kinds of different things on all sorts of different platforms.
Maybe one question, Richard.
Sure.
Are there any phaser games that are running on console? Because I see some people are talking about console games here on the chat.
No, because basically you have to be able to. Xbox X can kind of play browser games, so you can kind of like package an app for Windows to release on that, but PlayStation no, Nintendo no, because basically they although they kind of have browsers in them, there's no one's created kind of like a system yet that would take a browser and the JavaScript code and all the assets, bundle it together into a format that can run on a console. So unfortunately, like I said at the beginning, it's really difficult to get web games running on console. So it's kind of like if you're looking at doing straight console development, then you really need to be looking at the packages that offer that as kind of like a paid export option like Unity or Game Maker, for example. That's really the only way that's why they charge so much for it, because it's a lot of work to maintain those kind of build targets. So yeah, unfortunately not yet. I don't know, I hope it would be nice one day perhaps we can see like there are wrappers that would take any kind of like HTML5 game and wrap it to run on mobile, for example, as a native app. So it's not impossible, but it doesn't exist yet, unfortunately.
There is I think the web space is more exciting than console, right? Console kind of you kind of have to make it according to the rules of the console platforms, right? So you have to make in-app purchases, you have to burn games on DVDs. So I think it's better now on what we're doing, right? Yeah,
I think there's there's a kind of, it depends entirely what kind of game you're making, but I would imagine that hopefully the majority of people watching this are interested in creating blockchain games, which is naturally going to be quite problematic for console at the moment anyway. So we kind of, it's very early days, isn't it? So let's see how that kind of progresses in the next few years perhaps. But yeah, but I don't know, it's kind of, I think it was just worth putting this slide in there that making games full stop is hard work. And if you've got an idea, go for it, kind of use it, don't give up, take advantage of the communities that are out there. There are the Phaser community is huge, but you've also got massive Web3 communities, all of which will kind of help give input and feedback on your game. And it's very, very true that no one else will ever create something quite the way you do it. Your vision and your ideas are basically unique, so embrace that and don't be scared of it. Actually give it a go. And so kind of on that note, I think I would be nice to kind of dive into Visual Studio Code and actually go through the process of creating something. So if I stop sharing this and then swap it over. Cool. Were there any other questions, Paul, before I start doing this?
And I'll ask questions as they go in.
Okay. Right. Let me just share Visual Studio Code. Right. Okay, cool. So we should, yeah, there we go. Right, so basically, because Phaser is browser based and it's built on web technologies, everything starts with an index HTML, quite literally. So I'm gonna put a very basic HTML page in here that will do nothing other than load the Phaser library, load our source code, and just have a straight div in it. So I'm actually, rather than you watching me type it all out, I'm just going to paste it in. I think it would make a lot more sense. So if I just do this. Okay, there we go. Okay, right. So it's very literally, I'm taking the phaser distribution. So I'm not going to use any bundles or packages or anything. I'm literally just going to code straight in the a single JavaScript file and pull in the library externally. You obviously you wouldn't do it usually like this for an actual full production game. You would obviously use a bundler, so you can kind of like rely on node modules and all the other things that you like, and it produces like a nice small compact output. But for the sake of this, for this demonstration, I don't think that's utterly vital. It's the kind of thing that you can add on after you've figured out the game. So literally all we've got a completely empty page with nothing but a div in it, and that div's got an ID equal container, and that is where we're going to basically tell phaser, right, that's the div that we're going to stick our canvas in, please. And that is it. Aside from that, all I've done is taken away the margin and set the background of the page to black. Phaser obviously is the phaser library. Morales is actually a blockchain it's basically kind of like a chain server provider. So I'm going to be using their SDK in order to make like an on-chain query at the end of the game. Let me just save that. Right, okay, and my game.js file at the moment is just completely empty. So if I reload that, we should see that it's just black because we've just got a black page. Okay, so in Phaser works on the concept of a scene. So if I put in a scene here, I'm just gonna call my scene example because it's just an example game. Okay, and I'll stick in a constructor, which will just do that. And Phaser also uses a configuration. So I'm going to create a configuration object, and I'm going to do new phaser.game, and I'm going to pass in that configuration object. So the configuration object literally is what you tell it about how the game itself is set up. So in this case, we had a div called container. So we're going to say, right, that's our parent. That's where our canvas gets installed. We're going to give our game a width of 800 pixels and a height of 600. The scene above is called example. So I'm going to tell it to use that. And I'm actually going to put in, for the benefit of you, I'm going to put in a scale mode, which basically will make the game fill the browser window. Otherwise, it's going to be so tiny, you won't actually see what's going on. So I'm going to give it a fit scale mode. And fit Phaser will basically take your canvas and it will make it as large as it can do on the visible browser window without distorting it. Okay, so we've got our scene, but there's absolutely nothing in it. So if we reload this, like, it's just going to be completely black screen because there's nothing there. So one thing that we can do is get some assets. So Phaser has a function called preload, and we can literally do this .load. Oops, autocomplete messing around. Ugh, should have turned off. Set path, and I'm going to say, because I prepared a folder with some graphics in it before, while I was planning this, and so I've got a folder called assets that I put some like PNGs into. So I'm going to say, right, that's the path to load that from, and then we're going to load an image, and I'm going to call it background. And the actual PNG is actually called, I probably should have renamed this to make it cleaner, but it's actually called gradient 8. So the first bit, the background, is how you refer to it in your code. So Phaser uses strings for everything to help you figure out what's going on. So when a scene is started, it will do preload first. So it will load any asset that's in there, and then it will call a function called create. So if we do this, and in here, by the time we get into create, we know that everything's completed in terms of the loading, so we can then actually do something. So for this case, I'm going to add an image. We've got an 800 by 600 size canvas, so I'm going to stick the image in the middle, and we're going to use the image background. Okay, if I just save that and reload. Okay, and we literally have a background. That the kind of the blue gradient is our PNG effectively. If I was to kind of like change the Y coordinate down there, you'll see that it's kind of shifted down a bit. It's essentially the controls the positioning of it. Okay. However, it's great, fine, we've got a blue screen, but we kind of need something a bit more than that. So let's load up something else. Let's load up a face. So we'll load another image and face.png. Oops. Spell it right, it will help. Okay. And I'm just going to create a sprite. So basically the difference between an image and a sprite is that a sprite can be animated and it can have like physics. So it can kind of like bounce around the screen and do stuff. So there we go. I've got sprite. Oops. Again, in the center of the screen. Okay, and if we reload that, yay, there we go. Again, this is a handsome chap I found on Google Images. Okay, sorry, Paul, it gets worse. Okay, right. But now we've got the now we've got our sprite. We can do stuff to it. So we can do set scale 0.5, and then we've got a there you go, teeny tiny Paul. Or we could you know, do the opposite. We've got a much bigger. We could also change the angle of it. So if I'll comment that bit out and do face dot.
It's way too close.
Don't worry, you're gonna go a bit. There we go. Right, so basically, so angle literally, so full 360, so you can specify any degree on that at any point. If you prefer working in radians, you can use set rotation, but Phaser provides both because a lot of people find angles easier to visually comprehend. If we want Paul to be upside down, we can just stick it to 180. There we go. And we can also adjust the position of it as well. So if I do the so it's a bit of it like a 0. There we go. It's just kind of like peeking down from the top of the screen quite innocently. And you know, we can basically do anything we want here. So if I do minus 200, it'll be gone because you just a tiny bit of his hair up there. But before, like I said, we can Phase has a system called a tweening system built in, which allows you to move things around. So if we create a simple tween, I'll just do one here. Okay, so we're going to tell it to tween the face sprite, and we're going to tell it to tween the position to 100, and just that's it. So if we reload that, yay, there we go. We can also adjust it so we can make it run a lot faster. So we could say, right, okay, duration 500. So it'll pop down again, but it'll do it twice as quickly now. Boink. And we can also put a delay in there. So we can say a delay of 200. So we kind of like make him wait a bit. There we go, and then pops out. And we can also change the easing, which is where it starts getting fun. So if we do a bounce out ease, he will yay. And you can do an awful lot with tweens. I mean, they're quite powerful to say the least. So kind of let's just take this take the tween a bit further, I think. So I'm going to that's all right. I'm going to clear that out, and we're going to tween the scale of it so we can do something interesting. So I'm going to set a tween 1.3. So I want to scale him on the X by 1.3. So 1 is kind of like non-scale, so 1.3 would be kind of slightly wider, and scaled on the Y by 0.7. So basically he's going to shrink down a bit like that. So we're going to tween the scale X, and the duration, I'm going to do it at 250. I think that would be a nice duration. And I'm going to change it, the type of vist here. I'll do a sine ease in out. There we go. So we're not using the Y yet, but it doesn't matter. Okay, so you expand it out sideways. Yeah, it's quite straightforward, but let's make it do it on a loop. So if we just repeat it. Oh, okay. So let's make it yo-yo, so he's a bit more smooth. Yay, that's better. Okay, but we could also tween the other properties. So let's tween scale Y as well. So we're tweening both the width and the height. We got kind of like a jelly pool going on. And we can also tween the position as well. So let's tween it. We'll do it plus equals 100. So basically we're going to say, right, tween the position. So whatever it currently is plus 100 pixels and loop it like that. So if we save that, and it's getting better. And then we can also, let's have a look. If I copy this, and I'm going to take these out, and I'm just going to tween the angle when it's 20, like that. Duration, I'll make it this a bit longer so it have a much better effect. And that, so basically, you can create multiple tweens all on the same sprite. We kind of get a very, it's slightly disturbing, but you get the point. It's very straightforward to do stuff and get stuff moving. And with these values up here, I can change these to anything now. So let's try, I don't know, 1.8 and 0.4. Oh wow. Okay. So there's kind of there's quite a lot we can do with this. I'll stop him jumping around the screen now. I think it's probably fair enough. We'll just set it back to normal. Oop, nope, my mistake. I added a. There we go. Okay, fine. Things have calmed down a bit. But we can also we can make it interactive. So we'll literally do face set interactive. Help if I spell it correctly. So that will literally tell Phaser to take the sprite and allow you to click on it with a mouse, click on, touch it with a finger, multiple fingers, anything. That one call will do all of that. And then because it's interactive, it now emits events. So we're going to listen to the pointer down event. And when we get a pointer down event, we are going to react to it. So the first thing we could do, well, we could just make him vanish, I guess. There we go, gone, because I clicked him. But if I click up here, it doesn't do anything because it's not on his face. Or we could do, we could try, how about a set tint? Tint allows you to change the colors of a, the base colors of a texture. So if I do a set tint like this, oh, there we go. Nice red ball. And we can also, let's have a look. How about, well, let's just add a tween as well. So and alpha to 0. So if I really that, wow, and he's gone. So it's kind of it's pointless as that was in terms of a game. We've now got a completely interactive sprite. We have a sprite that's reacting to an input event. We can click it, and then we can cause things to happen to it purely based on the fact that we've actually touched that sprite. So let's take that a little bit further. I think I'm going to load in another image. So let's go back up to there. Let's start. Oops. And we'll start loading a coin. Would help if I were typed a bit slower. There we go. Right. So he's still interactive. I'm going to create a particle emitter. So particles are literally, you just do this .add .particles. And you give it the texture. So I'm going to give it the coin texture that we've loaded in. So it's created a particle emitter on the screen, but it's not doing anything because it hasn't been told to actually emit anything yet. It just exists. So we'll make the, I'll make it, there we go. Let's do particles.create. And again, as with most things in Phaser, it takes like a configuration object. So we're going to say that when it emits a particle, it's going to emit them out at an angle. We'll do, I don't know, 240. Again, angles done in 360. So an angle like that. And I'm going to give it a speed as well. Okay, and I'm going to give it a bit of gravity and a lifespan. So the particles will kill themselves after 4,000, so 4 seconds basically. And I'm going to say on false. False basically means it's not going to start doing it. We're going to do this based on clicking. So if I get rid of our tween from there, and instead I'm going to do particles.emit. Particle at, right, okay, and let's change this because we actually get a pointer, so we're going to use the pointer, and we're going to say pointer.x, pointer.y. Okay, and if I haven't made any typos, we should now have Paul, and yay! Look at that, it's just printing magic internet money. Okay, so however, we want to you know, one coin's not that great, so let's stick a quantity of 10 in there. That's more like it. Yay, Bitcoins everywhere. And let's actually make them. We'll make them scale because they're you know, they're quite large. So we'll make them scale between. So this basically the minimum scale is 0.5, so it would be half the size of the texture, and the maximum is 1. So just basically it will pick a random scale between those two values. If we do it, try again. There we go. So we've got like a mixture of large ones and small ones in there. And we can also make them rotate as well. Just make them look a bit more dynamic. So again, I'm going to start, so they can do a full rotation, and you can use an ease in the rotation. So I'm going to do ease out. Okay, and what do we have? Ah, look at that, perfect. And again, it's only on his head, so clicking up here doesn't actually do anything. Oh, and you can do as much as you like. Okay.
So much Bitcoin.
Right, so I'm going to I'm going to move this now. So because we've got, you know, that we can kind of we can use this, but let's use it not have it kind of like all sticking in the create function like this. So I'm going to copy all of this, and I'm going to stick it in a function called create particles. Okay, so it's exactly the same code. I'm just moving it into here to make it a bit tidier. I'm going to change the reference as well, so we can. Okay, so then I can just kind of like hide it, and you don't have to keep looking at it. And the only difference we need here is this dot particles. Okay, and if I reload that, so oh, hang on a minute, I've obviously got a typo somewhere. Oh yeah, no, I haven't. I just forgot to create them. So let's start create particles. There we go. Okay, so exactly the same again, but we've tidied it up and we've moved things down into our own little function just to keep it neat, so we don't have to worry about it too much. Because now we've got that, we can think, well, okay, what else could we do? How can we turn this into something that, you know, you could actually play? So I think probably the easiest thing to do would be to basically, let's make it so that, you know, there's not just one single sprite. Let's make a whole load of sprites. So we're going to create, I'm going to create a new function here. I'm going to call it create random face. And I'm going to give it a quantity as well, so we can, you know, make a whole bunch of them. So create a normal loop. That's quantity. Okay. And we're going to basically make sprites just appear at random coordinates on the screen. So in order to get a random coordinate, Phaser has a function called between, and you just give it 2 values and it will pick a random one between the 2 of them. So that's basically saying, you know, give me a random value between 50 and 750, because we've got an 800 pixel wide canvas for the X coordinate. And I'm going to do the same again for the Y coordinate, but it's a slightly different height. And then I'm going to do create the sprite in here. So, well, actually, we can just take the let's just take the code from here, be easier. Okay, and we'll give it the X and the Y. And I'm going to give it a scale. Let's do a scale as well, actually. So phaser.math scales floats, so values between 0 and 1. There we go. So we'll try that. And we're going to do face.set scale. Okay. And the last thing I want to do, I think, is just stick them all in a container for you. So create particles. I'm going to do here. This dot faces equals. So a container is literally just an object that you can put lots of different things inside of. Right. And I'm going to get a shot of all of that as well. Okay. So we're creating a container. We're going to create some random faces, and we're going to say, I don't know, 10. There we go. We got a scale in there, and we're going to do this dot. We're going to add the face to the container. Okay, and if I just run that, we should, yay, all over the place. Lovely. I think the scales are bit extreme. So let's take you down. So let's try that. That's more like it. And we're not limited to 10. We could have as many pools as we want bouncing around. So, so there you go. I'll take it back down to 10 for the sake of this. But so basically, all we've really done is taken the sprite code, put it in its own function, and used it multiple times because we want lots of them to click. Let's put the interaction back on. So I'm going to say face.set interactive again. And this time we're going to make it so that when you click it, it just vanishes. So I'm going to do once because you can only click it once. I'm going to do pointer down again. And the pointer is when you click it, it's going to call a function. Let's call it, I don't know, click face. There we go. Okay, so we need to create our click face. And it's going to take a pointer and a face. And we'll basically just do set visible false. Okay, so the whole point is that once the face is clicked, it will vanish. Yeah, marvelous. There we go. Slowly getting rid of them. Okay, but it would, but we kind of like had that particle system from before, so we can use that in here as well. So we've still got our particle emitter. So let's just do this .particles.emit. Oops. Particle at, and again pointer.x, pointer.y. Okay, but still just going to make it false. So there we go, and he explodes in a shower of Bitcoin every time you get rid of him. Okay, and then to kind of like take it a bit further than that, rather than just making the face just vanish completely, instead we'll tween it away because tweens are great. So again, we got the face. We're going to scale it down to nothing. So it kind of like goes shoop, and we'll do it quite quickly. So we'll use there we go, power. There are lots of different types of eases built into Phaser, and we're taking advantage of one there. So just pick that one there. Yay, there we go, and off he vanishes. I think there's coins are still a tad big. I might have to shrink them down a little bit. Let's go to 1.25 and 4.5. Is that better? Yeah, that's more like it. Okay, so I mean, fundamentally, we kind of like we've got we got sprites randomly appearing. We can click them, we can get rid of them. We get like a little reward when they've gone, but we still haven't actually really got a game out of this yet. So I think it's time to kind of like add a little bit more to it. So we'll basically we'll just stick a timer on there. So I'm going to put a score and a timer. So you have to basically try and get rid of all the pools as fast as you can in 5 seconds, and then you get rewarded with Bitcoin at the end of it if you manage to do that. So in order to do this, we need a score. Now Phaser has loads of text support built into it, so we literally just need to create a score, and I'll do it up here. So we need a value to hold it, so this is how many points we've got, and we need our text as well. So I'll do score text, and you just do this .add.text, again a coordinate, so it's the text is going to appear in the top like 32 pixels of the screen, and it's going to say score 0, and if I just do that straight away. Okay, so it's there, and it's using kind of like a little courier font because that's the default one. So we can change that, make it a bit bigger. Yeah, voila, perfect. Okay, and then so the whole point is that when he's clicked, we get a point. So we need to go into. So let me hide that one. So when we click the face. So we've got the tween in there, and then we would do this .score.++. So basically the score increases by 1 because we managed to do it, and we will update the text to show this. Let's try that quickly. There we go. Marvelous. 1 second. All right, so we're getting there, but I think kind of like that that's fine, but now we need to kind of stick some timers in there because at the moment it's still, there's still no actual challenge to it. So the easiest way to do that, I think, will be to add in, we'll add in basically, let's add in like a bar, like a timing bar. So it starts off like that. It just slowly goes like this. And once it gets to the end, that's it, you're out of time. Phaser has a load of timer events built in that we can just use. So I'm going to create let's call it a countdown sort of time.add event. And again, it takes a configuration object. So 5,000. So we get 5,000. We get 5 seconds to click all the pools. And we're basically we'll just do that. Actually, that'll be fine. And then we need to like the actual visual representation of it. So we call it timer bar. This dot. Oops. I hope I can spell rectangle correctly. Rectangle is pretty much what it says. It's literally just going to appear as a rectangle, and we're going to make it we'll make it green. Okay, so if I update that, we should see there we go. So we've got our time bar, but it's not actually doing anything. It's because we haven't added an update to make it change. So Phasers has literally every scene has the ability to create an update. This is called every single frame. So every time the browser refreshes, which is usually minimum of 60 times a second, it will call this function. So we can do all kinds of things in here. So we're going to basically say we call it timer bar, and we're going to scale it, and it's going to be this dot countdown.get progress, which is a function that just returns the progress of the timer. But it returns a value between 0 and 1 because it's counting up. So we kind of want the opposite of that. So I'll do -1. 1 second. So any luck? Yeah, there we go. So we have 5 seconds. Well, we don't actually have 5 seconds. We can just carry on playing. But fundamentally, we have the basis of a timer that's in there now. So when the timer expires, we're going to tell it to call a function called game over. So we'll say call back. Whoops. This dot game over. I think that would make sense. Check I've spelled that right. Oh, no. Needs that on it, doesn't it? There we go. And we need our game over function. So for now, we'll basically just make everything vanish. So faces.set visible. Okay, so try that. There we go. So we got 5 seconds, and if we don't do them in time, they're gone. So we can no longer click them. There we go. That's everything. So but we need to kind of like, at the moment it's still there's still kind of like no challenge involved. It's basically, I mean, you've got a bit of a time challenge, but anyone could really do that. If you could basically increase the quantity. So how could you get rid of like 100 pools within 5 seconds? I don't know. But let's add something that shows off how to use physics. I think that might be a bit more fun. So we're kind of like we're adding a baddie. Actually, let's add in another bit of the background as well. So I'm going to load up another PNG called grid, just to make the background have a bit more depth to it. And this will be positioned in a similar way to the background, but it's called grid. So if we reload that, there we go. Got a nice sort of 3D grid going on there. And then we'll add because we're going to be using physics, we need to add into the game configuration down here. I'm going to add physics, and I'm going to say, right, we're going to use arcade physics because that's all we need for this. And arcade physics basically is kind of like, it's a really basic physics system, but it'll be absolutely perfect for what we want here. And we'll say the gravity, we'll give it a gravity value of 80, for example. So things will kind of like, as soon as we create a physics body, it will slowly be pulled down as a result of gravity. Okay, and so, but doing that on its own doesn't actually, all that's done is enable physics within Phaser. It doesn't actually do anything else. So we're actually going to create something that we can use as a boss. So we'll create, let's have a look. We'll do it here, I think. Let's do this dot boss. Well, actually, no, we need an image first, don't we? So let's load in an image. Okay, body. Yeah, more typos. There we go. So, okay, we're going to create a boss. So this is slightly different. We're going to do this dot physics dot add dot sprite. There we go. So basically, we've created kind of like a physics sprite. So physics sprites can have their velocity set, and they can be set to kind of like rebound all over the place and do all kinds of fun things. So let's set the velocity on this sprite and just get it in there. So we'll do we'll pick a random velocity, so it can kind of like be going. It can start off and then fly in any direction. So we use exactly the same principle as the random position. So phasor dot math dot between, we'll do 300 to 400. It's quite a good horizontal velocity, and we'll do a vertical velocity of that, and then we'll just do this dot boss set. Okay, that should be fine. Right, let's see what happens now. Yay, perfect. We did have a boss, nice little, Muspet, he's just vanished off the screen. So we need to make him stay on the screen because there's no point having a boss that just vanishes after a couple of seconds. So we'll make him basically rebound with the edges of the screen. So I'm going to do this dot boss dot, see if I type this correctly, world bounds. There we go. So it's going to collide with the world bounds. There we go. If I do this. Ah, good, he's back to stay. Marvelous. Right, so I think the concept basically is you got to click all the pools within 5 seconds as quickly as you can, but if you accidentally click Elon, he's going to nick your Bitcoin, basically. So he's going to steal from you, and he's going to half your score. So I think that's kind of the approach we're going to go for. So we've got him doing what he's supposed to do. However, I think it doesn't look quite right the way he's kind of just bouncing off like that. So I think let's make him turn around and face the direction he's moving. So I'm going to use an event that physics has, which lets us know whether something hits the edge of the world, and it's called world bounds, and it's a body, and it gets sent these parameters. Again, I mean, I appreciate I'm going through this quickly, but all of this is covered in the documentation if you ever want to look into it. So we're going to basically make him, if he hits the left-hand side of the screen, we're going to just flip him around. And if he hits the right-hand side of the screen, we're going to flip him the other way. And flipping literally takes his texture. There we go. Marvelous. So now he's facing his grumpy direction.
Hey, Richard, just one question. Can the image be a GIF or like an animated PNG?
Right. Okay. So Canvas itself cannot display animated GIFs. You can load a GIF file perfectly fine. Like I could replace GIF up here. And it would load, but it would only display the first frame of it, purely because Canvas isn't capable of rendering an animated GIF. However, there are loads of online tools and third-party packages that will take an animated GIF and turn it into a sprite sheet. So it will extract every frame from it and lay it out into a single image, which you can then load in as a sprite sheet and then play as an animation. So that's the easiest way. So yeah, you could absolutely do that. So if you had Elon's face or his eyes blaring or devil horns, whatever, absolutely, yeah, no problem at all. You could happily do that, but you would have to kind of like compose the animation separately as kind of like a part of your sort of asset workflow, as opposed to being able to do it in the code here. But now we've got him in there, we're going to make him interactive, because if you click him, he's going to nick your stuff. So it's exactly the same way as we did with the making Paul interactive. So there we go, made him interactive, and we're going to listen to a pointed down event on him. Okay, and I think we're just going to call a function, because it's getting a bit busy in my my little create method. Okay, so every time you click him, it's going to call a function called click baddie. So let's add in click baddie. Okay, so you click him, he's gonna nick half your Bitcoin. So we're gonna take your score, and we're going to half it. And then we'll update the score text. Text dots to reflect this. Okay, so if we give that a try, that should. Okay, so we're clicking by mistake. Oh, there we go, down to 1. So yes, there we go, 4. Yeah, down to 2. Perfect. Okay, so that's working, but it's not visually great. It's quite hard to tell that you've actually done it. So we'll take advantage of some of the camera effects, I think. So we can access the main camera at any point by doing cameras.main, and I don't know, let's make it flash. So we're going to make it flash red. The first value there is the speed, so 250 milliseconds. So it's going to flash red for 1/4 of a second. So every time we click it, let's give that a shot. Ooh. Yay, perfect. There we go. So now you know actually what's going on. And just because, you know, it's Elon and he shakes up the crypto values of all sorts of things, we will shake the camera as well. So here we go. Ah, perfect. So now you know exactly what's going on and why it's going on. And then I think the other thing we need to do basically is to kind of like sort out the game over function, because at the moment when the timer counts down, everything's still happening, everything's still moving. So at the moment we've got we just want to just get rid of old baddie as well. So there we go. So let's score but it's nicked a few and time's run out and everything's gone. Perfect. Okay, fine. So just to kind of like I think probably what else could we do? Oh, let's make it so that so we'll make game over a bit tidier. So I'm going to take these out so make it a bit more fun. So first of all, let's just tweens.add. And tweens can actually take an array. So we can say, right, we are going to tween the faces and the boss and the score text all in one go. And we're going to say alpha out to 0 and take 1.5 seconds to do it. Okay, I'm pretty sure I've missed it. Oh yeah, I have missed it. There we go. Okay, so if we just try that quickly, and we have to wait 5 seconds. And everything should just go. Ah, there we go, marvelous. Right, so while that's going, I'm actually going to make a call out to the Morales network to basically kind of like get the current price of Bitcoin. So I'm actually I'm gonna paste this in because it's easier than actually typing these values out by hand, as you will see. There we go. So in our index, we import the library in here, so I can call any function on it. So basically, if you like create an account with Morales, then they generate servers and app IDs for you. So that's just all I'm doing here. And that value there, that's the contract address of Bitcoin. So basically, we're going to take that and we're going to call. We're going to say start. And we're going to call server URL and an app ID. There we go. Okay, and so we need an options object. So we're going to say chain, right? This we're going to use Ethereum, and we want the I'm going to pass it the Bitcoin token, and then they have a call called Morales.web3API.token. Have I got that correctly? Yes, that's right. And they've got a call called get token price. And then once they've done that, once it's returned from the network, it will come back. Okay, so for now, let's just check to see whether it has actually returned. So all I'm going to do, I'm going to take the text out of here because we're going to use it to see whether it's returned or not. So we're going to do, because there's no console, so I can't show you the console log on this. Oops, scroll down a bit far. There we go. Right. So the event itself has what we want in it. So we can get that from there. Event.usd price. There we go. And we'll literally just set that into there. And hopefully, assuming that they're up and the server's working and it's not too congested, after we get to 5 seconds, we should see our score. Ah, marvelous. There you go. That's the current USD price of Bitcoin, $38,000. Yeah, could be better. Right. So there we go. And
that's so low. One question, Richard, from from Sam around when you make the objects invisible, are they still there as objects? Like, can you still click them?
So input works on basically for input events, it needs the object to be visible. So you can't still click them once we've set visible to false. You can create hidden input areas. So you absolutely can create kind of like an invisible area of the screen that you can click. But you wouldn't, the way I'm doing it here is purely basically turning it off from all input because we don't want it to be considered for click events anymore. But you can absolutely create invisible hit areas too. There's a game object specifically for that called a zone, which has it doesn't render anything. It just has like a position and a shape. And then you can use those for like, for almost like creating like an image map as it were. So yeah, it can be done, but it won't here. So I'm going to add the, so now we know that the API is actually working correctly. I'm going to get rid of the score from here. We don't need that in there. All right, let's work out our winnings basically. So const winnings. So we're going to take the our score and multiply it by the price of Bitcoin. So I'm going to truncate it because obviously it's got loads of decimals after it. So score times BTC price. Okay, and we need to display this. So I'm going to do another text object. I'll do it in the, yeah, I'll do it in the middle of the screen. Okay, and we will do, no, actually, I'm going to use those u1. Yay, there we go. Yeah, I think that's fine. That's lovely. And we will stick we'll make it a decent size font so we can see what's going on. So 96 pixel Arial, and we want it aligned. So we want our text aligned. There we go. And I'm just going to align that as well. Okay, so basically all we're doing is creating a new text object because we've got rid of our score one, which is bigger and in the middle of the screen, and it's got 3 lines of text in it. So it'll say U1 and then a value and then an emoji at the end of it. So if we just try that very quickly, and then we're going to have to actually win something. So let's get rid of a load of pools. Okay, so we got 8. So there we go. Is it doing it? Yeah. Oh, wow. Blimey, that was very good going, wasn't it? $300,000 just from playing that. Okay, so we've got a text. It appears perfectly fine. We'll just quickly add a little bit more stuff just to make it nicer. So we will put the text at the top of the screen by default. We're going to say, right, you are going to tween and you're going to bounce down into place. And it's going to take 1 second. Okay, so that basically, there we haven't missed anything. No, I haven't missed anything. That's absolutely fine. Oh, hang on. No, we need some actual scores. There we go. Perfect. So now we got it just added a bit of juice to make it look a bit nicer. And I think because we've got our particle effect, we might as well just use it to just kind of like create kind of like a game over feeling to it. So I'm going to use another timer event. And it's basically called a delay. So it's a looped delay. So if every half a second, it's going to loop forever, and every half a second it is going to call this one callback. I think that's correct. Yes, that is correct. And this callback is basically going to again get a random position. Oops. 50, 750, and it's going to get a random Y position. 50, 550. Oops, so it's 600. And this dot particles dot emit particle at XY. There we go. So there. So basically, once it ends, you should. Right. Let's just do that. And for timeout. Marvelous. There we go. So we just get random coins exploding everywhere because it was easy to do. We had the function for it, so it just adds a nice bit of feeling to it. So fundamentally, we've now kind of, that's kind of pretty much. I want to leave some time for questions, ideally. So that sort of pretty much concludes what we can do there. There is an awful lot more that can be done. Obviously, the whole point was just to show that it's quick and easy to just get stuff up on screen, get stuff moving around, get stuff receiving input events, make calls out to third-party libraries such as this, get prices of tokens back. Morales has like a massive Web3 API. You can do all kinds of things. You can get all the metadata from tokens, get all the transaction history, archive history, all kinds of things. So, you know, absolutely anything you could think of in terms of kind of like what information you could get from the blockchain could be done from here. I was hoping to kind of like get some NFTs back, but then we have to deal with IPFS displaying images in here, which would have been a whole lot of mess. So I kind of think it is perfectly possible, but it's not something I can easily demonstrate here. It'd probably take another session to handle that. But yeah, I mean, but basically you got we could do anything here really now. I mean, we could kind of like maybe Paul needs to be I don't know, let's go create 50 of them. Maybe Elon needs to be a whole lot faster, so we'll make him, I don't know, 600 by 800. That should look a bit. Let's see what happens now. Oh yep. Oh no. How many can we get? 5 seconds. Come on. Rubbish. See, so you can just tweak in a few parameters. You can basically do anything now. If the actual code for this game is up on GitHub, so I will share that out if anyone's mad enough to want to play with it. But the game itself, actually, thinking about it, where did I upload it? I think it's on 1 second. Game test.mobby/kernel. I think it's there. Yay, there we go. So if anyone wants to play it, that's actually a live URL that you could use right now. And it should work on phone or desktop. But yeah, oh, look at that. I won nothing. What a shame. So there you go. That kind of like just a very quick dive into what's possible. And if you kind of like think back to some of the videos and the trailers that they showed, I mean, admittedly, there's a lot more complicated things that can be done, like massively more complicated games than that. But at the end of the day, these are the building blocks that you've kind of got, and you can kind of take them and start sticking them together and, creating anything that you can think of really, and it will run in a browser, and pretty much any browser you care to throw at it. So yeah, if anyone has any, I'll have a look at the chat now and see what's in there. But if there are any questions, Paul, I'm happy to answer them.
Yeah, thank you, Richard. That was a great presentation, really showing what Phaser can do. Aside
Sorry
from the faces. Yeah,
sorry for abusing your face
from
there.
The faces. Yeah, it's good. I think two things that I'm reminded of is we mentioned adding juice there. Just something that I would love people to think about is a lot of Web3 games don't have that juice, as you mentioned. The more successful games, when we say something is juicy, we have a lot of effects, we have a lot of feedback when we're interacting with the game. So Phaser will allow you to do that. You can add physics, you can add these particle effects. So it makes the game more fun, and frankly, it also adds more feedback so that people know what's happening when you're playing the game.
Yeah, absolutely.
And if anyone has any questions, and Andre, is there anything you wanted to add?
Yeah, I just wanted to add that I think it's kind of important to build a fun game first, and then try to apply NFTs or like coins into the game, because you want the players to have fun from playing, and then maybe have some tokenomics in the background. And Phaser is perfect for both quickly prototyping something and then building the full product. So totally recommend it.
Yeah, if you kind of like the last week's session, if you take all of the kind of like the scaffold ETH stuff that was shown in there, all of that, that's just literally pure JavaScript. Anything that was done there can be added into this Phaser game easily. So any of the token interaction that was going, contract interaction that was going on can be done. You kind of, the difference, I would say the only difference is between a traditional game and a blockchain game is that there's quite a lot of hanging around for events. So you need to make sure that your game is not blocking because you're waiting for a price to come back or a contract to fulfill. So there is that element that definitely needs to be considered, but aside from that, the world's your oyster, quite literally, I think.
Cool. Yeah, thank you for that, Richard. And I guess let's wait a few seconds for if anyone has any questions, or a few minutes. I'll just read through the chat as well. but yeah, but Richard has a great point there that what we did last week with Scaffold ETH and knowing what you can do with that and knowing what you can do with Phaser now, you can kind of imagine how to build games like what Richard has shown earlier, like Abigochi, or you can build your own Axie Infinity if you want, if you knew how to use those two tools that we've discussed. So yeah, thanks a lot, Richard. It was a really fun at the time spending it creating a game with you. And for the next sessions, I guess we'll move more towards the tokenomics of what kind of games we should be building. So now that you can make a play to earn game, or how do you kind of design the tokenomics around that? And we'll have a guest also to talk about that with us. So it's going to be less coding, I would say, more game design. And of course, Richard, you're welcome to join us if you're free also to kind of discuss around that
definitely.
Topic. Yeah,
it's
cool.
the biggest, most complex part of blockchain games, isn't it? So it's definitely.
Yeah. And then I guess the repo, I'll just get the repository from Richard, or do you have the?
I do. I'll
GitHub
paste it into
repository?
I'll paste it into the chat right now.
Okay. Yeah.
There we go. So that it's basically the repo's got all the assets and all the code broken down into little steps. So as I kind of like, you can see the different stages of it.
And that's Richard's GitHub account. So just take a look at the code he does there as well to learn more about Phaser. And cool, thank you everyone. So I'll stop recording the screen now.